Hi, this is Adrian from Live to Learn Academy, and today I'm going to be going over a Trigonometry Basics Masterclass. For those of you guys who are new to this channel, we post every day from Monday to Friday at 3 p.m. Eastern. And feel free to, if you're interested in tutoring, there's a link in our description. Feel free to click that link, sign up, and our tutors would love to get in touch with you guys. But without further ado, let's get straight into it. So when it comes to trigonometry, right, everything in regards to trigonometry all revolves around triangles. Okay, so triangles is the main concept when it comes to trigonometry. But within this triangle, right, you can have two different types of triangles. Okay, the first type is right-angled triangles, and the second type is non-right-angled triangles. Now, it's important to identify which type of triangle you're dealing with. Because if you're dealing with a right angle triangle, there's a certain amount of rules. And if you're dealing with a non-right angle triangle, there's another set of rules. Okay, so first you got to determine which one is which. Now, let's look at right angle triangles. There are three key things that you need to know for right angle triangles. The first thing is SOHCAHTOA, okay, for right angle triangles. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. The second rule with right angle triangles is you need to know Pythagorean theorem. A squared plus b squared is c squared. So SOHCAHTOA could be used to find angles or side lengths. Pythagorean theorem, on the other hand, is strictly for side lengths. And the last thing is called the interior angle law, which basically states that the sum of all the angles that are within a triangle should add up to 180 degrees. Okay? So with right angle triangles, we're always going to be using one, two, or three of these rules, and maybe in combination. Now, with non-right angle triangles, it's a little bit different. Non-right angle triangles are actually split up into two different departments. The first department is sine law, and the second department is cosine law. Now, sine law basically suggests sine A over A is equal to sine B over B, which is equal to sine C over C. Cosine law, on the other hand, has a completely different formula. C squared is equal to A squared plus B squared minus 2AB cos C. Now here's the thing when you're using sine law or cosine law. The first option you want to check is cosine law when you have a non-right angle triangle. But the second option you want to check is sine law. And what do I mean by that? With cosine law, there are two cases that you need to know for cosine law. The first case is if you have three sides and no angles. So there's a question where you have a non-right angle triangle like this, and the question gives you three sides but no angles, you know for sure you're going to be using cosine law. The other option, so the other case, is if you have two sides sandwiching one angle. Okay, so what does that look like? So if you have a non-right angle triangle, you have two sides, let's say this is A and B, and they're sandwiching an angle C. Okay? If you have these two cases, you are for sure going to be using the cosine law. If you don't have one of these two cases, then you would be using sine law. Okay? This is why I labeled cosine law with a 1 for you to check that first, and then sine law with a 2 for you to check that second. And mind you, these all have to do with non-right angle triangles. Now here's another thing about non-right angle triangles. Let's bring this flow chart down here. They also use this rule. Angle A plus angle B plus angle C equals 180 degrees. So once we get two of these angles, we're also able to use this formula to find the third angle. So notice how the interior angle law applies for both non-right angle triangles and right angle triangles. Okay. Now let's move forward a bit on this flowchart. If you have a right angle triangle, right, you can use SOHCAHTOA, Pythagorean theorem, or interior angle law. But also, with right angle triangles, there's this thing called special triangles that we need to know when we're doing trigonometry. So there's two types of special triangles, and mind you, this is still right angle triangles, okay? There's two types of special triangles. And these are two triangles that you should memorize. The first, you have so if we're talking about, I can do them in degrees and radians for you guys. So you have 60, 30, 90 triangle, where the side lengths are root 3, 2, and 1. And the second triangle is the 45, 45 triangle, where it's 1, 1, and root 2 as the side lengths. So this is if the special triangle is in degrees. If it's in radians, it's going to be the exact same thing, but we're going to put them in radians, okay? So the only thing that would change is that this would actually be pi over 3, and this would be pi over 6. Whereas this would be pi over 4 and pi over 4. Now, these special triangles are important because they give us certain trig ratios that we need to know. So there's a couple trig ratios that I want to list out for you here. So let's look at the first one when it comes to this triangle, and we're going to do them in radians. So this one, we're going to have sine pi over 3, cos pi over 3, and tan pi over 3. And then we're also going to have sine pi over 6, cos pi over 6, and tan pi over 6. Okay, so let's look at these ratios and find out what they are. So sine pi over 3 is going to be opposite over hypotenuse. So we will have root 3 over 2. Cos pi over 3 is going to be adjacent over hypotenuse, which is 1 over 2. Tan pi over 3 is going to be root 3 over 1, because it's opposite over adjacent. And then after that, we got to do the pi over 6. So that means we're talking about this angle now. Sine pi over 6 is 1 over 2. Cos pi over 6 is root 3 over 2. And tan pi over 6 is 1 over root 3. Cos pi over 6 is that. Okay, cool. So now what we have to ask ourselves is, are all of these good to go? Are they fully rationalized? Now, if I look at all of these terms, we're good here, we're good here, we're good here, we're good here, we're good here. But if you look over at this tan term, you have this root 3 in the denominator. Anytime you have a square root in the denominator, you cannot leave the question like that. Instead, you have to rationalize the denominator. So how do we rationalize the denominator? We multiply the bottom by root 3, and whatever we do to the bottom, we do it to the top. So in the top, we're going to get 1 root 3, which is 1 times root 3, which is just going to be root 3. And the bottom is going to be root 3 times root 3, which is just going to be root 3 squared, which is 3. Now, this is in a better form that we can use for these questions. So these are how we find the common trig ratios for these special triangles. And we're going to do the same thing for the other special triangle. But the good news about this one is it's just sine pi over 4, cos pi over 4, and tan pi over 4. So sine pi over 4, we get 1 over root 2. Cos pi over 4, we get 1 over root 2. And tan pi over 4, we just get 1 over 1, which is just 1. In this case, this one is good, but these two are not good. And the reason they're not good is because we cannot have the square root in the denominator. So we have to multiply top and bottom by root 2. So what we're left with is root 2 over 2 and root 2 over 2. And now both of these are rationalized. So these over here are all just the primary trig ratios. Okay? So this is the basics, guys, when it comes to triangles. The first thing you want to determine is it a right angle triangle or is it a non-right angle triangle? After you determine that, right angle triangles have a certain set of rules. SOHCAHTOA, Pythagorean theorem, and interior angle law. Non-right angle triangles have a certain rules as well. It can only be sine law or cosine law. And the key is we want to use cosine law first to determine if it's one of those two cases. If it's either 3 sides with no angles or it's 2 sides sandwiching one angle. If it is one of those cases, we use cosine law right off the bat. If it isn't one of those cases, we then transition to sine law. Now, also in non-right angle triangles, we also have the interior angle law that applies to that as well. Angle A plus angle B plus angle C is equal to 180 degrees. And the only difference is that when it comes to special triangles, we are going to be using that for the for the right angle triangle side, and that's where we actually have our primary trig ratios. So if you found this video helpful, feel free to keep an eye out for more videos like this. I'm going to be dropping trigonometry masterclass videos this whole week, so feel free to keep a look at, like, subscribe to the channel, and I'll see you guys in the next video.